Okay, this video is 3.2 parallel lines and transversals. So in 3.1 we learned about transversals. Okay, we learned how they cross two or more lines and the different types of names that we have for angle pairs that they can create. In this lesson specifically, now we're going to have transversals that are crossing parallel lines only. Okay, so parallel lines, remember, they're never going to touch. They're the equal distance apart all the way across. And so we'll see some different relationships that these angles have now. Not just being able to name those angles, but special properties that they have. So the first one we have is corresponding angles theorem. Corresponding angles theorem tells us that when we have parallel lines that are cut by our transversal, notice we have our transversal over here of T. Okay, that line will be our transversal because it crosses two or more lines. So in this first one, corresponding angles, it tells us that our corresponding angles are going to be congruent. Okay, so notice here it goes ahead and tells you that 2 would be congruent to angle 6. Corresponding angles are going to be the ones that are in the same position on each of the lines that it intersects. So 2 is up here on the top right. Okay, and if I color it in kind of with this purple color, okay, this would be my 2 here. Then 6 would also be the corresponding angle here. Okay, so 2 and 6 are going to be congruent based on corresponding angles theorem. 3 and 7 would also be corresponding, and so they would also be congruent. So 3 is the bottom left, 7 is the bottom left. So here we have those two. Then there's some other ones. This is only one example. We could also do 1 and 5, those are corresponding, and so they're going to be congruent to each other. And then we also have our last set there of 4 and 8. And so 4 and 8 would also be congruent with each other. Then we can look at alternate interior angles theorem. Okay, alternate interior angles are angles that are on the interior of our two lines that are transversal cuts. So interior is going to be everything that's on the inside here in this light blue. So alternate interior, alternate refers to being able opposite of each other. Okay, so when I'm thinking about alternate, they're going to be across from each other. So if I'm looking at the interior, my 3, I'm going to cross to go over to my 6. Okay, and those would be alternate interior. So I would go across. So I have 3 and 6, and this theorem tells me that those angles are also going to be congruent. So 3 is going to be congruent with my 6. Then I can also do my other two ones that are inside. I have 4 to 5. I go alternate. I go across my transversal. So 4 and 5 are also going to be congruent angles. Okay, congruent means same size, same shape. So they're going to have the same angle measure as well. Then when we look at the next one, we have alternate exterior. Okay, so our exterior is going to be the outside portion. And so I'm going to put it in this light yellow here. Okay, so that is my exterior. So alternate exterior is going to be in the exterior. So we're looking at 1, 2, 7, and 8 in the yellow. And again, they're going to be alternate. So I have to cross over my transversal to get to the other side. Okay, so if I'm looking at number 1, I'm going to go from 1 across my transversal to the other exterior of 8. So 1 and 8 would be my alternate exterior angles. And then I can do 2. I go across all the way down to this other exterior of 7. And so those would also be congruent. So we have these 3 theorems that tell us about congruent angles. The last one is consecutive interior angles. So once again, we're looking at our interior, this light blue area inside here. And so consecutive angles are our ones that are on the same side of our transversal, okay? So if I'm looking at the interior, my same side is going to be like 3, same side. I'm not going to cross my transversal, and so I'm going to have 3 and 5. Same side on the other side of my transversal is going to be 4, same side down to 6. And I'm told these ones are going to be supplementary. Okay, they're not going to be congruent like the other 3. They're supplementary. So if I add them up, if I look at these statements down here where it has 3 and 5, I can do the measure of angle 3 plus the measure of angle 5 is equal to 180. I could do the same thing for 4 and 6. So if you look on our diagram here, 3 and 5, they sum to be 180. 4 and 6, they sum to be 180. They're supplementary angles. So in this problem, example 1, we want to know the measure of three other angles in this diagram that would also measure at 120 degrees. So here we have, it looks like this would have been like the number angle 1, if you look at how they're numbered. So we have this 120 degrees here. So think about what we know is congruent, okay? This angle is on our top left. So congruent angles, we could either look at corresponding angles, we could look at alternate interior angles, and we can look at alternate exterior angles. Okay, those would all be congruent. So think about this one. First, let's think about our corresponding angles. So corresponding angles are ones that are in the same position. So if this one is top left of my intersection point here, then I want to know top left of my other intersection. So that would be angle 5. So that would be one of my answers. Angle 5 would also be 120 degrees. I could write it out as the measure of angle 5 is 120 degrees. That's the only corresponding angle. So I can also think about now my alternate interior angles. 5 is an interior angle, so the alternate interior with 5 would be my 4 here. Remember 5, alternate interior, I go across my transversal, and I have to think about the interior. My interior would be here in between my 2 lines. This is my interior. So 4 and 5, so that would mean now I can say 4, measure of angle 4, is 120 degrees. And then my last set of congruent angles is my alternate exterior angles. So exterior, I have the 120 that we started with. It's an exterior angle. And I need an alternate angle with it as well. So I'm going to cross my transversal, go to the other side of my exterior, and so I would be looking at angle 8. So the measure of angle 8 would also equal 120 degrees. So in example 2, now we look at being able to solve for values if we're not always just given numbers. So in the last example, we just had the number 120. Now we need to solve for x. Okay, so notice our 115 here is this top left of this intersection. Okay, so if I thought about corresponding would be a top left. Well, that doesn't really help me yet. I don't have my variable there. Okay, instead I have my variable on this top right one. Okay, so first think about 115 and our x plus 5. Okay, they do not have any sort of relationship. We don't have a way where we connect this exterior and this interior angle. Okay, because they're not corresponding, they're not in the same position, and one's exterior, one's interior. So we have no correlation. We don't have any theorems that tells us about that. But we do have this angle 4 here. Angle 4 and angle 115 are formed by 2 intersecting lines. So remember, 2 intersecting lines, my angles that are across from each other are what we know as vertical angles. And vertical angles are always congruent. Okay, so 115 and angle 4 are the same. So the measure of angle 4 is equal to 115 degrees. So now if I know angle 4, what relationship do angle 4 and this x plus 5 have in common? They're both interior. This inside portion here, this is the interior. And they are on the same side as our transversal. To get from 4 to this one, I don't have to cross over it. So my same side is my consecutive interior angles. So if we go back, notice on our slides that we had before, consecutive interior angles, okay, they are supplementary. They're not congruent, they're supplementary. So, in this example, angle 4 and my other angle, they're going to sum to be 180. Okay, these two angles here, they sum to 180 degrees. So I'm just going to write that in. So I could do the measure of angle 4. Let's do a darker color because we can't really see that. Measure of angle 4 plus this x plus 5, I'm going to leave it in parentheses, would equal 180 degrees. But we know the measure of angle 4. Angle 4 is 115. We already set up here. We already figured that out. So I'm going to have 115 plus my x plus 5. I can get rid of my parentheses by distributing. There's only an invisible 1 here in front of it. So when I distribute that 1, it doesn't change anything. So I still get 115 plus x plus 5. I combine my like terms, keep solving, so I get x plus 120 equals 180. To get x by itself, I would subtract, so I end up getting x is equal to 60. I was just told to find the value of x. That's what I've gotten, so I'm done. Example 3, we're doing basically the same thing. So notice here on this top one, we have this 136. And then we have angle 1, they've just put there, and we're trying to find x again. X is this bottom right angle over here. Okay, all these angles they've listed are on the exterior, so the exterior is outside of our lines. Okay, so if this is our exterior, they're all in the exterior. So 136 and the 7x plus 9, they are on the same side of the exterior, right? I wouldn't have to cross my transversal to get to them. Well, we don't have any properties on that one. All we have properties on is our opposite side's exterior, right? So if I'm looking at this 7x plus 9, opposite of it would be this 1. So we know alternate exterior angles are equal to each other, so I could write out that the measure of angle 1 would be equal to our 7x plus 9. But I can't solve for x yet. I would need to find the measure of angle 1. Well, notice in our picture, angle 1 and this 136 are on a line. Okay? If I take the degree measure of a line, it's always going to be 180 degrees. So that means they sum up. They are what we call a linear pair. Okay, linear pair adds up to be 180. So I can write this out as an equation, and I can write that the measure of angle 1 plus 136 is equal to 180. Now I just have to solve. So I need to get my measure of angle 1 by itself. So I subtract 136 from both sides. I get the measure of angle 1 is equal to 44. So now if I have this 44, now I can substitute it in up here. So I'm going to keep writing out. So instead of measure of angle 1, I'm going to now take this down. So I'm going to write 44 is equal to 7x plus 9. I just need to solve. This is our algebra. So subtract 9 from both sides. I get that 7x is equal to 35. Get x by itself, so I divide by 7 on both sides. So I get that x is equal to 5. I was told to find the value of x. That's what we've done. So we're finished. Again, this part is all algebra. Most of this here, all this work we did, this is algebra work. It's being able to recognize in our diagrams. That's the geometry part, being able to know these angles and what their relationships are.